I'm Francisco Campoy, and this is Just for Funk. So welcome to episode number 25. We're going to continue today with what we were doing before, talking about AST and parsing programs and stuff like that. But this time, rather than answering the question, what is the most common identifier in the standard library, we're going to answer a slightly different question, which is, what is the most common name for local variables and package variables, also known as globals, in the standard library? And in order to do that, rather than using the scanner, we'll need to learn how to use the parser. Does that sound fun? Let's get started. Okay, so the important thing to know here is that in the previous episode, we were working with a sequence of bytes, which is a program, the source code, and we were using the scanner to convert it to a sequence of tokens. Now what we're going to do is we're going to convert that series of tokens into a tree. That tree that is constructed by following some rules. Those rules are actually part of the Go program specification, so you can find them on the Go program specification page, which I recommend to read. I think I've recommended many times to read that document, so you should probably go and read it. It is pretty easy to read, although very deep and useful for anyone, no matter your level. So if you've never read it, go read it. If you've read before, it's time to read it again, probably. Anyway, so in there, we're going to see things like, well, a variable declaration is something that starts with the keyword var, with the token var. Then there's a series of names. Then there's an equal, maybe some types, and then some values, right? And that is a specific rule, and you can find it in the standard library, like right this. Now, once you have those rules form a grammar, which also we call a syntax. And once we generate a tree from those rules, then we have an abstract syntax tree that we call an AST. And that's what we're going to be using today. We're actually going to analyze a program not from token by token, but given a whole tree of the program, we're going to be able to find the pieces that we care about. Let's get started writing some code. So I'm going to create a main.go file in my parser directory. And this program is going to be doing something quite simple. So rather than using the scanner as we did before, we're going to be using the parser. So I'm going to import that. Import go parser. And parser dot has a bunch of things. One of them is parse file. And that parses a whole file. So we need to pass a file set token, which is, as the previous episode, just something to basically hold information about all of the files that we've parsed. And you create one by doing token.new file set. So that is the files that we're going to pass. Then we're going to pass the file name, which in this case, rather than passing the file name, I'm going to pass directly the code directly into the next one. So here I'm going to pass, say, var a equals 3. And then we have the mode. And the mode for now, we're going to do parse all errors. And basically that says, please parse all of the things. We'll see other modes in a little bit. Okay, now it fits in the screen. So when we have parse file, that returns a file and an error. If the error is a nil, let's log fatal. Otherwise, let's print f. And we'll see what this actually does, because I'm not sure printing the tree by itself is going to be very useful, because it's just a bunch of pointers and stuff like that. But let's keep it like this for now. Let's keep it simple. Okay, so go run main.go. And this says expected package found var. And this makes sense, right? Because we said parse file, and any Go program starts with package, other than for some comments before. So we need to write package main here. And I'm going to use a semicolon. You could also use a line break. Okay. If you wanted to parse something that is an expression like 3 plus 5 and stuff like that, you could use the parser.parse expression for this. But what we're trying to parse is a var thing. That var is not an expression, it's a statement, it's a declaration, so it will not work. Okay, so let's try it again. Cool, so now it works, and we get this thing that Not incredibly useful, but we can see that indeed there's main and then var a. Let's try to print something a little bit more valuable with the pound v that gives all of this. We can see that there's a pointer to file that has a name, which is a pointer to an identifier that has some declarations and some scope and some imports and stuff like that. Not very useful like this either, but there's a cool program, a cool package. It's called spew, go spew or something. Will this help me? Go spew. There you go. So this package here allows you to do spew.dump of the file, and this should give something slightly easier to read. There you go. So now it gives us an idea of what this tree looks like. We start with a pointer to file, has comments, there's no comments, has the package, which is actually a token position, it's in position 1. Then we have the name of the package, which is main. And then we have a bunch of declarations. Well, actually just one, length is 1. And that declaration doesn't have any comments. And that declaration has a bunch of specifications, in this case only one. And that is the declaration, the identifier a, and the value 3, which is an integer. Cool, so that is a tree. That is the tree that we are talking about, right? So now that we have this, how do we go inside? How do we extract information from that tree? We could go and write our own program, but there's actually a better way of doing this, which is using what's called an AST visitor. So what we're gonna do is we're gonna be using stwalk. And stwalk is a function that gets two parameters, a visitor and a node. Now, when you pass a visitor, the visitor it's an interface, and the node is also an interface. Any node in the AST is a node. So for instance, this F, which is a pointer to file, is a node. Declaration is also a node. All of those things are kind of nodes. A visitor, though, is something interesting. What is a visitor? Well, a visitor is an interface with one single method, visit, that given a node returns a visitor. So we're gonna need to implement one of those. I'm gonna call it visitor v and just do this for now. So let's define visitor. For now, let's make it an empty struct. We don't need any context in here, because what I'm going to do is every single time we call visit on a node that returns a AST visitor, it's gonna return itself at the end, but before that it's going to print the type of the node, and n. Okay, so now if we do this, not happy. That visitor, oh, it's not a pointer. It's because it's an interface. You don't pass pointer to interface. That's kind of weird. Okay, so that compiles. So now we run this. What we're gonna get is, boom. We're gonna have a file, an identifier, general declaration, value, spec, and identifier, basic, literal, and this kind of makes sense, right? This looks like the nodes we have in the tree. Now, the problem is that we actually lost the information of how deep they are, which is kind of a problem. And also there's a bunch of nils. Why are there so many nils? Well, the solution to this is, surprisingly, to read the documentation. So if you go to the visitor type here, you will see that a visitor, not the visitor documentation, but the walk documentation. You will see that so traverses an AST in depth first order. It starts by calling visit node must not be nil. If the visitor W returned by the call is not nil, walk is invoked recursively with visitor W for each of the non-nil children of node. So basically, if I'm at file, and the visitor that I returned will be used to call it on all the declarations and all the nodes that are like children directly, not descendants or grandchildren or whatever, just children. If it's nil, then we stop. And at the end, once we've called all of the children of a single node, we call nil. And that's what we're seeing here. That's all of the nils, right? So what we can do is we can do a little game here. We're gonna make our visitor be an integer, and that is the depth of the tree. So then we could add strings.repeat int of v, and we're gonna return v plus 1. Now if we do this, we're gonna be printing something with indentation. So if we run it, boom, this actually looks like a tree, which is cool. Now we should just ignore the nils because we don't really care about them. So if n is nil, then just return nil, because also we know it's the last one, so nothing else is gonna be called with it, so it's cool. So there you go. Now we see that for our code package main var a equals 3, we get a file, an identifier, which is the identifier for the package, which is main, and then a list of declarations, with one of the declarations being some identifier a with some basic literal 3, and that is our AST. Cool. Now, knowing this, how are we going to do it so we can extract the information that we want? Notably, all the variable declarations, which could be things like this, but also it could be func main a equals, let's call it b equals 2. This is also a variable declaration, right? And we want to also keep those in mind. So you run it, you will see that there's inside of the function declaration, that is the function main, there's a function type, which is nothing. Block statement has an assignment statement, and that assignment statement is also variable declaration. So we care about assignment statements and we care about value specs. Those are the two nodes that we're gonna try to understand. So let's change the code that we wrote last time for the parser in order to adapt it to our code today. So I'm going to get the scanner code and just pass it here. Okay, so things I need to change. We're not gonna have a counter. Instead, we're gonna have a visitor, var v visitor, that we'll define later on. We don't need to read the file really. We don't need to scan it. We're just going to parse it. So to do that, we're gonna do parser.parse file, and we're gonna pass our file set, the name of the file itself. Then we don't need to pass the content, and parser.all errors, and that will be if the error is not nil. Since we're going to be parsing many files, it's better to just log it and continue, because if we just do log fatal, it will never work, because in the standard library, there's pieces of code that do not compile, because they're tests. So we should not just panic there. So log print could not parse this file because of this reason. So the file is arc and the error is this, and continue. Otherwise, we're going to do ast.walk visitor and f. Let's see. And then this part where we print the top 5 elements, we're gonna move it to a function, func print top 5, that giving a map does all of these things, and we want to use all of them. So if you don't know what this code does, go watch the episode 24 that explains how, what this actually does. Basically, it just prints the 5 more common elements in this map, taking into account that the key is the name of the identifier and the int is how many times we saw it. So we need to declare our visitor. Type visitor is a struct. And what we need to do is we need to have a map for locals. So map string of int, map string int, and also globals, map string int. And when we call visitor visit ast.node, we're gonna return ast.visitor and return v for now. Okay, so now what we want to do is we want to do something only when we see a type of node that we care about. So to do that, the easiest to start with, actually, if the node is nil, just return nil. Otherwise, we want to do a switch on the type. So switch, let's call it D, which is declaration. That's why I want to call it D. So n.type. And if the case is, so let's start with colon equals, because we know that they're always local. That's easy, right? You're gonna do a colon equals 3 outside of a function. Therefore, all of the variables declare like that, they're locals always. So let's do that. So it's gonna be an assignment statement. So case AST assignment statement. Just print. Let's print. Not the type, because we know the type. Let's print d dot. Let's see, d dot left hand side. That is the names on the left hand side, which are the things that we're declaring. Also, we should be able to say that if the token is not token dot colon equals. Is there a colon equals thing? Let's see. Define. Okay, so if the token is not defined, we should continue. We should return v. Because if the token is just var, it's just a equals 3. We know we're not declaring anything, so we can ignore it. So okay, so let's run the program. Oh, we need to pass a parameter. Let's build it and use parser. Let's use it on itself for now and see what we get. Mendoco. Okay. So we see that we have f error pairs I and d, and that looks pretty good because we have so fs is here, so that's a colon equals. The this one here doesn't appear, which is interesting. We should fix that too, the range. So let's see. Let's just put it here for now. Case AST.range statement. And if we have that, we're gonna print the key and value. So d.key and d.value. Okay, so now we can see the R and S and N. So this looks better. Okay, so I think this might be enough. So we have switch appears already here. The range statement now appears. We have also the if statements, but I'm pretty sure that they also appear. So let's see, do I have any done? No. So let's try it here. So if I do if L and L minus 2, we see L here. So if statements appear, for statements appear, switch statements appear. So we are good. Okay, so let's start with our assignment. So LHS. LHS is a slice. So what we're gonna do is for every kind of name in range the LHS, name is, let's print its type for now. So name, so we can know what we're working with. We have identifier, and that's what it should be. If it's anything else than identifier, it's not a declaration. So we're good. So we're gonna do if name as an AST identifier is okay, then ident.name. Cool. So if the name is underscore, we're gonna ignore it. Continue. Otherwise, we're going to add it to our visitor. So visit.locals of ident.name plus plus. And that panics because we didn't initialize this correctly. So let's initialize this correctly. We need to give a mat from string to int and another one. Okay, so at the end, we're going to print the top 5 for v.locals. So we saw VFSD. Okay, so that looks pretty good. I have a concern though. I'm going to create one folder test, and inside test.go. So if you do a equals 3 and ab equals 3, what we should see is that a is declared only once, because here we should not count it because it's already been defined before. In order to make it actually compile, let's AB. So these, 3 and 2. Okay, so this one is a declaration of A. This one is not a declaration of A. It's just a statement. It's an assignment. So how do we check the difference between those two? Right now, if we run go build and parser over test.go, we'll see that A is declared twice. The thing is that in order to know whether this is a declaration or not, what we're going to be using is the object. So there's this variable here that points to an object, which is what is this object referring to? What is this identifier referring to? And one of the things it has is it has a position. Where was this declared? So what we can check is if the position is the same one as the position of this declaration, then it means that this is a declaration, right? So if the place where this identifier has been declared is this place, then we know that is the declaration. So if we run it, now we see it only once. Just in case, I'm going to say that object should not be nil. Because if the object is nil, then it means that it's something that either has not been declared and it's not declared either here, or it's been declared in a different file, and then it's not a local declaration either. For the range statement, we should do something similar. So if the.key is an AST.identifier, and identifier.name is an underscore, we continue. Otherwise, we actually going to do exactly the same. So let me just do it count identifier, count local identifier of name, func count local identifier, and we're gonna get a node, AST.node, and we're gonna do so that is what we're going to do. We also need to pass our visitor, and continue. It's gonna be return. Okay, so what we're gonna do is let's change this a little bit. Like this a little bit better. So we are going to do count local identifier of name via name, and similarly here we're gonna do count local identifier of d dot key and count local identifier of d dot value. So v and v. Cool. So let's modify the test program to try it. So for a equals range int 1, 2, 3, print a. We should be able to see that a has been declared right there. There you go. So a is nil. Oh, we're still printing this. We don't need to. Okay, so a appears once, which is cool. And if we have a b, should have a b, a b. And if for any reason we had this, we do not see any of them, var a, b, because they're actually not declared there, they're declared on top, and we still not handling this. So this looks okay. Cool. So we're able to count the assignment statements, we're able to count the range statements, we're pretty good. Now what we need to do next? We should count the other one, the var statement. And that is a little bit more complicated because we could have something like var a equals 3, or we could have var b equals 2, right? And they look exactly the same. So in the node that we're gonna receive from the tree, so in the node that we'll see inside of the tree, we will not see a difference between these two, between A and B. We need to actually keep track of what are the declarations that have been done at the package level. So what I'm going to do is I'm going to have a package declaration, which is a map of AST gen declarations, which is the type of any declaration. So when you have var or const or type, those keywords there, that will generate a gen declaration, and to boolean. And what we're going to do next is we're gonna need to initialize it correctly. So I'm going to move this to a new visitor, and let's do a new visitor of ast.file. Return. So what I'm going to do is declaration is going to be a map of that type. And we're going to go over all the declarations in the file. So for range f.declarations, if declaration is an AST dot value spec, that is when we're declaring either a variable or a constant, we're just going to say not that, sorry, v comma okay is that and okay. We're going to keep track of dex of v equals true. And then we're going to be able to use that list when we are receiving, not happy. Value spec does not declare, it's not value spec, it is value. Let's see, what are the declarations? A gen dec. There you go. And that is, yes. Why is this not happy? Oh, equals true. There you go. And this returns a visitor. A visitor. Okay, so now we're gonna need to move this a little bit because the visitor is going to be created right after the file has been parsed because we need that parser. And then we're gonna need to keep track of locals and globals, which are going to be both map of string to int. Whoa. Okay, and for key value range visitor the locals, we're gonna need to add to increment the locals. So key v and range over globals, and do the same. Globals of key of k is plus v. And then we're gonna print locals, mass, common, local variable names, and I'm lost. There you go. And most common global variable names. Makes sense. Okay, so if we do a equals 3, we should see. Okay, so we have most common local variable name so far is 1. It's a, the previous only ones. That is okay. That looks pretty good. Okay, so what we need to do next is to add one more case, which is case AST gendecle. And the first thing we need to check is if the token is not var, then we should ignore it, because it may be a constant, it may be a type. We do not care about those in this case. Otherwise, we are going to go over the the specs. So for spec in range specs, spec is of we don't know what. Let's simply print it for now. Print the type so we can continue easily. I do this all the time when I'm not really sure what's the concrete type that I'm dealing with. I don't know if it's a good practice or if there's better ways of doing it, but I think it's pretty useful. Okay, so we have a value spec, which is as we expected actually. So if value okay is spec dot this and okay, what we're going to do is value dot. So we have names and we have values, and the names are going to be all of the identifiers that are either local or global. We still don't know. So let's go range over this, range over the names, and let's print them from now. Print ln name of name. So we should be able to see A and B, which are defined A and B. So var A, var B. So the last thing I want to do is I want to verify that this declaration is not a global declaration, or it is actually. So the way we're gonna do this is if the dot package declarations of spec, then v dot globals of name dot name plus plus, else v dot locals of name dot name plus plus. Also, we should ignore if name dot name equals underscore. Just continue. We do not care about that underscore. Cannot use type spec as type in map index. Oh, that's actually D. Okay, so now we're seeing B and A. And so let's go real quick about the whole thing. Our visitor is checking if there's an assignment, and it checks those assignments. If there's a colon equals, then it checks the name, and it checks if whether it's a local or not. If it's a declaration or not. Same for range statements. And then for general declarations, we check that it's a var something, and we check whether it's underscore. And we also check for global, so whether it's a global thing or not. Let's make sure that this is actually working. I'm gonna remove A from here. We should see that B appears as a local variable and A appears as a global variable. That's exactly what we want. Cool, so I'd say that this code is good now. So let's finish by actually running it. So I'm going to go build parser, and let's do again over all of the Go files in the standard library. Some of them will not work, which is fine because there's tests. And now we can see that the most common local variable name is error. Not shocking. Also X and I. If you remember from the previous episode, the most common identifier was V. But that one doesn't even appear anymore, which makes me think that that V either was a type or a constant or something like that, or probably an identifier that was defined not that often, but was used very, very often. That is my intuition about the problem. About the most common global variable names, we have errors, signals, failed, test, and debug. And something interesting is how people say, well, in Go, we always use very short variable names. Well, that is true for local variable names, but for common global variable names, those names are always full words, which I'd say is the best practice. If you have a local variable, then yeah, sure, go for I. But if you're going for something bigger, well, go for tests or errors or signals, or actual words that make sense. So this is the end of the episode. I hope you enjoyed it. Let me know if you want me to continue with this series. I think it's a pretty interesting series on program analysis. There's more to see. Do you want to talk about types? We did not do anything related to types in here, but there's way more we can do. Let me know if you want me to cover other topics. You can always send ideas to forum.justforfunc.com. You can also get in touch with me on Twitter as Francesc. And finally, I just wanted to have a quick note. Thanks so much. We just passed 10,000 subscribers in the channel. If you're not subscribed yet, why don't you click subscribe? Let your friends know. Also, huge thanks to the patrons that are supporting me on patreon.com. There is, I think, 45 of you right now, which is amazing. It's blowing my mind. And it's allowing me to have mics that float in space. So thank you so much. And to all of you, as always, thanks for watching and see you all in 2 weeks.